Hi, this is Tim Fairfield, Keysight Technologies. I'm going to talk to you about the mainframe user time-based calibration that's on the DCA N1060 module and on the DCA. The purpose for this calibration, and even if you've bought a new DCA and a new DCA module, you should be performing this user time-based calibration when you're trying to get best accuracy. And that means things like EOJ, anything with PAM4, anything that's in 56 gigabaud or higher. It's highly recommended to get the best repeatable results by doing this procedure. Now, let's talk about this. What do you need? We have a PSG. I'm using the E8257D, the 256 kilohertz up to 67 gigahertz PSG. You do need a stable signal source that can generate at least a 26 gigahertz signal. If you look down on the bottom, I am showing the RF output, and that is then sent along to a power divider. I'm using the 11636B power divider. It's only 26 gigahertz. So if you can imagine, if I'm going to put a frequency of 26 gigahertz out, I'm going to have to boost that amplitude at that frequency. If you have a higher bandwidth power divider or a splitter, that's fine too. You just won't have to do any amplitude boosting when you're doing the 26 gigahertz tone. So this will split out. Once you split this out, you would take that and connect one to the trigger input on the front of the a DCA itself, so that one needs to be triggering that, and the other end needs to be going into the N1060 precision waveform analyzer, either channel A or channel B. You can select that in the GUI. I suggest having couplers on the ends that are 2.4 millimeter if you can. Otherwise, you're going to have to change those out, and that just makes an extra step that's unnecessary. So if you are doing this on a semi-regular basis, I would just recommend you have cabling or apparatus here that would match exactly what you're doing, so you don't have to keep removing these heads and changing them out just for the purpose of this calibration. Next, we want to get a general idea on the amplitude, so we can put it in free run mode. When we move along here, I'm showing that 26 gigahertz, 1.49 volt amplitude. And just for your interest, if a signal wasn't coming out when you're using the PSG, there's an RF out button on the bottom. Let's go through the process of a complete cal. First, I am selecting Timebase mainframe user time calibration and next. Before I continue, the one important thing is that the DCA must be warmed up for 60 minutes so it's stable. And the PSG also needs to be warmed up 20 minutes, 25 minutes before it is stable, depending on the model that you're using. That way you'll get, again, repeatable results. If you try to do a mainframe user time-based calibration and the DCA has not been on long enough, you will get a warning and it'll give you a timeout. Now starting calibration. This doesn't take very long. It goes pretty quick. So it starts with the 26 gigahertz tone, which we've already set up. And again, the amplitude, they'll give you a guideline on that. And you want to make sure that your amplitude is in the ballpark of what's saying here. It's pretty easy to do. So this is the process. And now I'm going to stop here. And now it says, please connect a 3 gigahertz clock signal and make sure the amplitude is between 280 millivolts peak to peak and 980 millivolts peak to peak. Now press frequency, select your new frequency, 3, then press the gigahertz button. 3 gigahertz. And now the amplitude is really high. Now that's going to give you a warning that it's clipped. Obviously, we don't want to leave that running in. So it's too large. We're not going to be able to continue. So the next thing is we'll set the amplitude. So let's press the amplitude button. There we go. Amplitude and 800. I'll give you 800 millivolts. Should do the job. Millivolts. So it's going to continue on and finish the calibration. So we'll let that run. And again, this does not take very long. So it's completed. So essentially at that point, it's giving you the okay to continue, reconnect the signals, whatever you've disabled, and plumb it back the way you want it. And that is it. So again, the mainframe user time-based calibration.